Hi, everyone. Thank you all for showing up today. I know it's probably been a long week for a lot of you here at South by. It's really been a spectacular week for us. My name is Myra. I'm here with my colleague, Brian, over there. We're from Republic. We're co-hosting this fabulous event with the Prysm, folks. They're amazing people. Today we have some very exciting guests, but before we go into our talk, just wanted to say a quick 30 seconds about Republic. Republic is an investing platform. We help crypto companies, crypto and blockchain companies raise both privately and publicly. We have the ability to make VC introductions with our current product called Radar. We also do syndications. And our latest project is we're launching our own token. So we'll be distributing free tokens on our ecosystem. We encourage you to reach out to us after this talk and learn more about it, either with myself or with Brian in the back. And again, without further ado, I'll just let Stephanie and Preston introduce themselves.
Hello, everybody. Welcome. I assume we're going to use microphones. That's it. All right. Thank you, everybody, for coming. My name is Stephanie Hurder. I'm a founding economist with Prysm Group, and I am extremely thrilled to be in conversation with Dr. Preston McAfee, who's here. He has one of the coolest resumes I've ever seen. So a bit about Dr. McAfee. So following a quarter century in academia at Caltech and the University of Texas, he was one of the first economists to move from academia to a major technology firm. He joined Yahoo in 2007 as their chief economist and has mentored and hired many of the economists that now work in tech today. He later moved to Google in 2012 as Director of Strategic Technologies. In 2014, he joined Microsoft, where he served as the Chief Economist until last year. Dr. McAfee combined his leadership roles in industry with continuing research. He is an inventor or co-inventor on 11 patents in such wide-ranging areas as search engine advertising, automatically organizing collections of digital photographs, and adding user-defined gestures to mobile devices. When he was still a professor in the 1990s, he and two Stanford University economists, Paul Milgram and Robert Wilson, used auction economics to design the first Federal Communications Commission auction of Spectrum. Among his current activities, Dr. McAfee advises the FCC, mentors and advises many early-stage companies, including Prysm Group, of which he is a senior advisor, and serves on the board of the MIT Institute for Data Systems and Society, the Pardee Rand Graduate School, and MSRI. So, welcome. Thank you for joining us.
Thank you. And actually, I'm not on the board of the MIT. I'm just on the visiting committee. That is, I help write a report on what they're doing.
There we go. Great. So we're going to have a conversation for about half an hour to 45 minutes, and then open it up for questions. All right. So starting off, so a lot of people think of economists as people who sit in the ivory tower, talking to each other and nobody else. As one of the first economists to move from academia into tech, you've obviously had a lot of interesting experiences using economics in the real world. So I was wondering if you could start by telling us a little bit about one of those adventures.
Sure. Let me correct one thing, which is that I was one of the first microeconomists. There were macroeconomists studying things like unemployment and demand for tourism and so on, have been in companies forever. What's really changed in a big way is the use of microeconomists. And so these are people who study game theory, who study market design, who run econometrics. And most of the tech companies at this point have hired a chief economist who's a micro person. Amazon has the most with 150 microeconomists, but Microsoft, Google, Zillow, Uber, Facebook all have hired, and many others have hired microeconomists. Just as an example of things that we did, at Yahoo we faced this issue of how we allocated digital advertising. So this is display advertising. And one of the issues, and one of the sort of major roles for an economist in it, one of the issues they faced is that the bulk of the money came in contracts that were guaranteed contracts. That is, the customers, so Toyota or General Motors had said, give us 10 million impressions to a particular demographic. And there are various ways you can serve that demographic. And that is, you can find, let's say, women between the ages of 30 and 50 at lots of different websites. And it's going to matter how which ones you pick and serve to, say, Toyota. And the computer scientists who were building the algorithm had just about gotten to the point where they had agreed that they were going to use the greedy strategy. And here's how the greedy strategy would work. You've got people who are bidding for the ads. They're bidding an amount per person or per ad. So Criteo is a famous company that does this. They come and participate in auctions. Meanwhile, you've got Toyota who have just this very general description of who they want. So the greedy strategy says, give the absolute worst inventory to Toyota and the best inventory, which will sell for the highest price, to Criteo. And in the very short run, that makes you the most money. The thing is it's only in the very short run that this is a strategy for cutting your own throat. And so that was one of the economic roles at Yahoo, was to look at the economic side of the picture and help devise the strategy that would survive for the long haul.
Got it. No, so I know some of the people in the audience are market designers, and I think the story of how you worked with the FCC to design their first Spectrum auction is really inspiring. So I was wondering if you could tell us a bit about that.
Sure. Let me start by saying being in the right place at the right time is really lucky. It's really helpful to be lucky, and I happen to be just in the right place at the right time. So I had worked on auctions for much of my career prior to 1994, and in 1994, the legislature ordered the FCC to auction Spectrum. And here's why they did that. So for most of us, half a century, they had allocated by administrative procedure, which meant you went and asked the FCC for Spectrum, you made a case for why that was in the public interest, and if they agreed, they would give it to you. And all the television spectrum was allocated that way. This both took a long time, and it also didn't respond to markets, right? It responded to, what did the FCC think? But mostly it took a long time. So then they said, let's see if we can speed this up. And the next thing they did was hold a lottery. And 400,000 different entities requested Spectrum in the lottery. The Boston cellular license went to a consortium of dentists. RACG Associates. And it was just speculation, right? If there's a lottery, and if the tickets are cheap enough, you want to buy tickets, right? Relative to the price. So the government ordered them to auction. That is, the legislature ordered them to auction because this was such a bad idea.
And just to clarify, what type of spectrum are we talking about?
So this became the first generation of cellular licenses. The second generation. The first generation of smart cellular licenses. 1994. So I was in the right place at the right time for the following reason. In the order that ordered the FCC to auction the Spectrum, they cited a paper of mine. I'd written a survey about how auctions work, and they cite that. And so I, not surprisingly, got called in. Milgram and Wilson, the other two people that were discussed, also were cited. That's how we come to be influential. And because nobody knew what was a good idea, we had an outsized influence because we understood how auctions worked, and basically no one else involved in the process did. The key, so we followed the way you do this in almost all market designs. First, you try to understand what the biggest issues are and optimize for those. So here, the biggest issues were we didn't know how the spectrum should be allocated. And let me give some examples. If you look at the earlier licenses that had traded, what you got was aggregations along interstates. So I-10, a single company owned from Texas all the way to California, and they had geographically, so you could drive I-10 and never have to roam, right? Never have to go off your carrier. But what's the right allocation? Well, you can't really sit in a room and think about this, and everybody involved in the process who wanted to buy Spectrum had a different preferred allocation. So we wanted to use market forces to figure out what was the efficient allocation.
Right. And my understanding, let me know if this is correct, is there are sort of two dimensions of spectrum. There's the different bandwidths, and then there's different geographies. So it's like this big puzzle, or at least that's how I think of it. Yeah.
Yeah, that's correct. And in fact, when we got to the cellular spectrum, we were going to auction just 2 licenses per geographic area. So that is 2 different bandwidths. But prior to that, because we wanted to, so we developed an auction that used bidding inside the, the geographic issue is this. If I want to win Dallas, it matters whether I'm going to win Houston. The value of Dallas depends on whether I take Houston. Why? Because I get roaming between the 2. So if Houston closes first, then I'll know how to bid on Dallas, but it's kind of too late. Like if Houston was cheap, I might want to turn the clock back and bid on Houston. So you need to be able to know one to bid on the other and to know the other to bid on the first. So you want them to operate simultaneously. Well, if you've ever participated in a charity auction, that's kind of the way it works. That is a charity auction. You know, you go and write things on different items trying to win the ones that you want. Prices rise. But charity auctions have this awful feature that they all end at, let's say, 8 p.m., and you can't be in 2 places at once. So you can really only make sure you win one of them.
So one of the things that's, I think, particularly interesting is that the interplay that you guys had between sort of thinking about the theory of this and bringing it into different sort of lab and experiments. So could you talk about that a little bit?
Absolutely. So we came up with a design that allowed the auction to stay open provided that there was enough bidding activity. That's kind of the key thing, is as long as prices are rising at a sufficient clip, the auction won't close. If it slows down, then all of a sudden you kind of go into overtime and it closes. Unless you get enough bidding activity. And that says I get to substitute back and forth what I want to buy. There's some wrinkles I won't talk about on this, but it was a new auction design. Nothing like this had ever been run at scale. So what we did to test this is a guy named Charlie Plott, who's a professor at Caltech, coded it up in his lab and starts running it first with Caltech undergraduates, and then with Caltech undergraduates are kind of unusual. They are unbelievably smart. And so then we ran it with like more normal people in his lab. And that gave us confidence that at least some populations would behave the way we thought they might behave, or the way the theory predicted that they would behave, even in kind of real circumstances.
Got it. And so then my understanding was that the first people who brought you on board for this were actually some of the companies that would have to bid in the auction. That's right?
Yes, that's right. In fact, I worked for the company that becomes, it was Pacific Telesis, which is the wireless division of Pacific Bell, which then becomes AirTouch, which then becomes PCS Prime Co., and is now, like so many of them, rolled up into AT&T.
Got it. So, and one of the things we think about a lot at Prysm is how do you convince people who aren't economists that market design is necessary, and an auction algorithm like the one you're designing is what you need. So how did you get everybody on board that this was a good idea?
Yeah, so that's a great question. It's got kind of a multifaceted answer. So first, we ran these experiments, and that gave us a certain amount of confidence that this is the way the auctions would actually behave in the real world, and that convinces a certain segment, a relatively savvy segment. Not everyone is convinced by those experiments. I actually went on the road with a big jar of either peanut M&Ms or other colorful candies. And you've probably done this thing where you guess how many are in the jar. So here's what I did: is I'm selling an envelope. It's got money in it, and it's got an amount of money that is, think of as 10 cents per M&M. And we're looking at a whopping big jar. So there's $20, $30 in this envelope. And I had people bid. And in a group this size, I can tell you that consistently I would get over $50 for selling an envelope that might have $25 in it. My record was 140. I got $140 for a $20 bill. That was in that particular envelope. There was a $20 bill, and I got $140. But I had 500 people in the room. And here's the thing about the way auctions work: is if you overestimate the value of something you're bidding on, it's called the winner's curse. You're going to bid the highest. So we went on the road to show, here's the kinds of auctions, well, in particular, Christie's had a recommendation which involved a lot of ping pong paddles for how to run the Spectrum auctions. And they also wanted 25%. And this sold in the end for $10 billion. It would have been a pretty comfortable living for them. So we went and ran auctions in front of telecom executives to get them comfortable with, I had two facts I wanted to press on them. One was, this was going to be a really complicated thing for them. When they went to bid on these auctions, they didn't know what it was worth yet. They're going to learn from other bidders what other bidders are willing to pay, and they're going to want to be able to substitute based on the behavior of other bidders. And so that was one of the goals. And the other was, look, some of the designs really are awful for you because you're likely to lose a lot of money. And this, by the way, so there's a thing called a second price auction. A second price auction is like a normal tables and chairs auction. The price rises to the point where the second highest bidder drops out. And at that point, the remaining bidder wins, but at a price where the second bidder dropped out. You can run that as a sealed bid just by saying the high bidder pays the second highest price. That auction is much more resilient to making mistakes. If I overbid, it takes two overbidding to cause the price to go up. Let me add one more thing to stay on your question. So the final thing we did was convince the Federal Communications Commission that let's run a little auction first. And we ran the paging frequency. So this was at a time when the first digital pagers were coming out. By the way, you can still buy a pager, but that's only got another month to run or something. When the first digital pagers were coming out. So we ran paging licenses to illustrate the behavior of the auction before we ran the one that ultimately raised $10 billion.
Right, and it launched and it was successful.
Very. It's been copied around the world. More than $100 billion is run through this auction form worldwide. I was on the cover of a magazine associated with it, and both of the major parties in Mexico agreed that the auctions we ran in Mexico were a success, which, by the way, Mexican politics is like the rest of the world, or at least the developed world, where if they like it, we don't. and so that was a very unusual thing. It's and continues to be run to this day is the Spectrum auctions that we designed.
Got it. And so we're going to talk a little bit more generally in a little bit about sort of general principles for economic design that are helpful for blockchain. But one thing I want to touch on now is that, a lot of platforms are very excited about using auctions. So I know that the other founding economist of Prysm, Kathy, was presenting at DARPA a couple weeks ago, and Vickery auctions were everywhere. So this is for those of you who are auction theory nerds, this is a sealed bid second price auction. And people are just really excited. So just generally, what would your advice be as an expert auction designer on blockchain projects considering using auctions?
So the general principle is fit the design to the circumstances that you're running. And so some circumstances, a second price auction is just the best thing you can do. Like I said, the second price reduces the risk. When you have more than one good, the Vickery auction starts to get complicated. That is, the proper notion of a Vickery auction doesn't look like high bidder wins pays the second price. It's now what would have happened if I take one of the bidders out, what would have happened, and so how much did the bidder contribute to the overall payments or societal benefits? Those auctions get really complicated. They get complicated in a couple of ways. One is they're very much subject to, first it's an NP-complete problem, so just computing the prices is very hard as you have lots of items. If I have 4 items, it's no big deal. If I have 1,000 items, it all of a sudden becomes such that, you could run all the computers in the world for months and not get the answer.
Right. So there's a number of different ways in which the circumstances can be different, and one of them is the number of things you're actually trying to auction. Yeah.
And a second thing is, the Vickery auction is sensitive to collusion in a way that other auctions are not. And so that is, the Vickery auction creates a great incentive for two bidders to join. And it can be the following, it can be that the prices fall by more than if the two bidders weren't even present. So if they collude. So it can be financially extremely lucrative for bidders to collude. So if it's an auction where you're not worried about collusion, that's a plus in the case of Vickery. If it's an environment where you're already worried about collusion, and you're worried about collusion when your bidders get together a lot, they play golf together, they have other reasons that they might talk with each other. The Vickery auction is really dangerous in that circumstance.
Got it.
By the way, in the real world, the largest Vickery auction is Facebook's digital advertising auction. It's the largest example of a real Vickery auction run anywhere, to my knowledge. Well, let me say it was the largest for sure.
Got it. But yeah, so this, building on this, just the idea that, the details of the auction design matter, and just because Vickery auction sounds cool doesn't mean it's the one for you.
Yeah, it has to fit the circumstances.
Got it. So stepping back, and we'll come back to some of the economics in a bit. So you're one of the few economists who's published in economics. You're actually one of the co-editors of the leading journal in economics, the American Economic Review. And you've also published in computer science and math. So what is your view on the difference in perspective between CS and math and economists?
So the great thing about being in the tech sector was I actually worked with really smart people from very different disciplines, and I learned a lot from them. And economics brings something that winds up being quite important often to the table, but it's hardly the only thing. Let me just get, a lot of what I've done at the tech firms is involved in pricing. And pricing is often it's got engineering issues. Like if you're selling services, so we did Azure, my team did Azure pricing at Microsoft, still does. I just don't lead it anymore. So if you're selling a service, you actually have to be able to monitor. Like if I want to charge based on some characteristic, I have to be able to monitor that characteristic. So that has engineering costs and implications. So that's one thing. If it's really complicated, it may be very hard to explain to the customer, which makes a very potential downside on risks that the customers either won't like it or will find it. We'll make lots of mistakes with it and so on. And so marketing often helps get that right. And what we typically brought to the table on this was both how much market segmentation is there, that is, what's the right kind of segments, and how much money can we make by segmenting the market. So that is, if I charge two different groups, two different prices, how much leakage am I going to get? We could estimate all that. Let me put one other issue on the table that economics brought to the table, which is Microsoft. They're hardly unique in this. They run their sales on hardware, on their biggest sales on computers and so on, at 2 times: back to school and the winter holidays. This is when demand is highest, right? So the time that they have the lowest price is when demand is highest. If you just put AI or regressions or any other straight out statistical technique and look at the data, you overestimate the value of lowering your price. Because the times that Microsoft or Apple or any of these companies lower their price, they get this massive boost in demand. And this is tantamount to, if you run the regular statistical analysis, it's tantamount to saying if you don't cut your price, Christmas won't happen. Right? The holidays don't come. So disentangling the causality, that's something that economists help with on the empirical side.
On the empirical side, and I think they also, we like to say that they really do contribute to thinking about things in terms of individual choice. So thinking about, what are incentives, and people can't necessarily be programmed. And so how do you design environments so that people choose what you want? You've been asked a lot. I know you've been asked by pretty much every tech company, what do you see as the economic value of blockchain? So what do you think are sort of the main economic benefits that you can see being used widely?
So actually, as part of this, I've had a lot of economists say, what are you doing at South by Southwest? And so I've now worked out what has worked pretty well in answering that question, and this is answering it to someone who has no idea what blockchain is. And the answer I like to give is, so I have a bank account. I can go on an app on my phone and look at the balance of that. If someone stole money out of that, I would see when I went to that, maybe, depending on how they stole it, that money had been taken out, and I could raise an alarm at that moment with the bank. There are two problems with that. One is, depending on how the money was stolen, I can't necessarily see, right? It could have been stolen, but they've somehow tricked the system into still telling me on my app that it wasn't stolen. The flip side is, even if they didn't do that and I now see it, and so I take a screenshot so I can prove that this is when the money came out, it's pretty easy to change a screenshot, right? I can get on Photoshop. There's a wonderful website, Photoshop Disasters. I can go into Photoshop and make that say whatever I want. So it's not really a proof of anything. So what blockchain enables is this kind of nuanced, I can see what I'm allowed to see. We can make that public in a way that I know that I'm actually looking at the authoritative document, and yet I can't read anyone else's bank accounts. I can't read stuff I'm not allowed to. To add to that, I bought a car. I just wrote a check because I'm an American and we write checks and no one else in the world even knows what this is anymore. I had to be able to prove that I had enough money in the account that the check wouldn't bounce. Well, what we did in practice is, it was on a Sunday. We went down to the ATM. I withdrew some money from the ATM, and that puts the balance, and then I could show what the balance was. Doesn't really protect them, because I could, of course, empty the account and fly off to Libya or whatever, but bring the car somehow. So you can now do this kind of nuanced permissioning of, I'm going to show the car company that I have that amount of money, and I'm not going to tell them anything else. Right, and that kind of nuanced permissioning, there's nothing out there like blockchain that can do that. So it solves two kinds of problems. One is this, I only want to reveal part of the information. And the other is, I don't trust the party that I'm dealing with, or at least I don't fully trust them. And I want something that's a public document that says, this is the state of the world, in a way that I can verify if they ever try to change it. And those are, I would point to, are the biggest innovations that we just didn't have before. There's nothing like that technologically available.
We think a lot about what is this going to mean for economic activity in general. So one of the things we were talking about earlier is, we're thinking about something called the Holdup Problem, which is basically, how not having joint control over an asset can lead to changes in investment. What are the ways, do you see any ways in which this might actually affect sort of the industrial organization or the organization of markets?
So I think there, actually, so let me give a kind of high level thing. A lot of companies don't use internal markets. It did actually, there was a flurry of it in the 60s of let's run internal markets inside the company, and you saw, but that kind of fell out of favor again.
What do you mean by internal markets? Can you give an example?
So let's use prices to guide decisions within the company. And actually, one of the key questions companies always have to ask themselves is, should we make it or should we buy it? And that is to say, should we rely on a market to produce this item, or should we make it ourselves? And there are pluses and minuses to both of those. Holdup is one of the reasons you might want to make it yourself, right? If there's only one supplier, making it yourself is a way of having two suppliers and having the option of if your one supplier tries to hold you up, you've got an option. So that's an example of where you might want to make it yourself. Using markets actually even to decide, do I make it myself or do I buy it? That is, and the nuance or the challenge there is, what I don't want to do is shut down my internal production so that I'm now subject to holdup. So I want to do something in the way of long-term contracts. I think blockchain may have a role in that for the reasons we've talked about. Two parties who don't fully, they trust each other, but trust but verify. They don't fully trust each other. They want stuff in writing. They want stuff verifiable, and it's kind of complex. Blockchain actually is a nice technology for embedding complex contracts, and even with markets. So that is to say, my blockchain may have, I need to buy 2 items that work together. 2 different suppliers can now submit a bid that winds up being a joint bid through a blockchain. And in a way that they can verify where they stand and adjust their bid if they don't, if they're not winning, they're not tentatively winning, because they've got that nuanced permissioning. So that's just an illustration of how that might be used.
Got it. Yeah, I know it's an interesting way you can start to think. There's an overlap between sort of thinking about complex market design questions and what the type of market design you could do when you have this kind of data set up. You can think about what are all the different partnerships that could be engaged in, and then how do we write contracts so that we can actually, make these kind of fancy, multi-party deals. So I'm curious about, working on all of your years of market design. Obviously you've designed a number of markets now. What would you say are some of the key sort of points that you want people to take away from market design?
So a really big one, and one that let me say, this is a reformulation of things I had not fully understood at the time of the Spectrum auctions, of the 1995 Spectrum auctions. So a design can either be very expressive or not. And by expressive, what I mean is, let me just give the example of geographic regions. Can I buy downtown Austin, or is Austin just one unit? A more expressive auction might be at the zip code level rather than the city level or the state level. So by making it just that finer, and they talk about this as expressiveness because it's kind of the language. Am I allowed to say I want to buy downtown Austin in an auction? So on the one side, you have expressiveness. What's good about a very expressive design is that if the efficient thing is for me to have only downtown Austin, that becomes possible. So the set of possibilities grows. There are 2 downsides, though. One is it just became very complicated. So the amount of time I'm going to spend trying to figure out how to bid or how to participate grew. That's bad. That's a pure cost. It's a social waste. It didn't do anything other than, it's lost. It's lost production. The second thing, though, is that I'm more likely to make mistakes and not get the right thing. And that has to be so yes, the possibles got bigger, but the likely thing may get worse. And you have to trade off, are people going to make more mistakes, which harm social welfare, harm the quality of the outcome. And so often, depending on the setting and how savvy the participants are, how important specialization is, you always face this trade-off of how expressive do you want it to be.
Right. And I think this is something that, a lot of projects we see think about is that, there's when you give people an incredible amount of choice, and for example, there's an eBay competitor where you actually program your own auction format. So they literally just give you you can program in whatever you want. That's great for the early adopters, but that's just way too much, right, for most people. So in general, are you more, do you tend to come down more on the simpler side or the more efficient side? Because economists are always talking, made fun of for being too efficient.
So the interesting answer there is it depends on who I'm working with. When I'm working with computer scientists, I'm almost always on the side of more simplicity. My quip that got widely quoted when I was at Yahoo was that left to their own devices, computer scientists will recreate the Soviet Union. And the reason is, if you've got 2 programs running side by side, you can almost always make them more efficient by integrating them. Economists have this kind of hate, the economists like things that run autonomously and independently, and so we don't like that. So we serve as that's just so complicated you can't replace a piece of it now because the 2 pieces interact. Anyone who's dealt with legacy code knows this issue. And so with computer scientists, I almost always am the voice of simplicity. But put me with the finance people, or the marketing people, and I'm the voice of complexity. Is that and there's actually one exception even to the computer scientists, but the marketing people often say, let's just have one product. Actually, it's a marketing truism that the sales force will only sell 3 products, so why bother to make more? Make your top 3. By the way, I quoted that a lot when I was at Microsoft, is that, look, the top 3 products are getting 94% of the total spend. Really, the products 6, 7, and 8, they're not really serving much of a role here. And they add complexity to the system, which can cause problems.
Got it. Another thing that we were talking about in terms of sort of lessons for market design, I had a really great question. So yesterday I gave a session and I was talking about how market design has been used to assign students to schools. And I got a really great question that I think brings up a good point, which was someone asked, if market design is so great, how come the schools in New York aren't any good? Like, why is the public school system so terrible? And I think, what this brings up is sort of, market design can't fix everything. It's dependent on the resources that are available to it, right?
Yeah, that's absolutely right. So market design doesn't make a teacher better. It may make classes work a little bit better because it may get the assignment of students to schools a bit more efficient. That's certainly what happened in both New York and Boston. And by what do I mean by that? What I mean is, if you poll the parents and say, is your child in a better school than they were last year? You get 90-ish% saying yes. That's a huge success. It actually has gotten up to 94, something like that. That's a huge success of those systems. But what it didn't do is that jerk of a teacher who's not paying any attention and not doing any prep and assigning grades at random didn't change that at all. So it doesn't change your underlying resources. It changes how you allocate those resources. But if the resources themselves are already inferior, there's not much. You can't fix that with an auction.
And you can't fix it with a blockchain.
And you can't fix it with blockchain.
Yeah.
You can probably make it worse with blockchain, but you're not going to fix it.
Got it. So moving on, continuing with blockchain is that, we know at Prysm that a lot of blockchain projects are really building economic systems from the ground up. And of course, everything is, constrained by its environment, but you really have the chance to start from scratch. Right. And so we get questions about, this is almost an overwhelming task. How do we think about a good process for designing an economic system from scratch? And this is something you've actually had to think about and do. So what would be some of your sort of advice on how to proceed when you do this?
So I always start with what the participants are trying to accomplish. This is just first thing is to understand what is it they want to accomplish. So in the schools, the big thing that they're trying to accomplish in the schools is that the parents can put the kids in the schools that are actually suitable to the kids, which has to do with both geography and busing and all of those things. So start with the PCS auctions. I went and talked to not just the company that had hired me, but a bunch of other companies about what it was they were trying to accomplish and the things that they were worried about and what good outcomes looked like and what bad outcomes looked like. So you start by just understanding the environment. And that actually often simplified, because if you just sit in your room and say what a thing people think is important, there could be lots of things that are potentially important, and it often turns out that 3/4 of those really just don't matter to the participants. So when we sold microwave spectrum in Mexico, the number one thing that most of the companies were worried about was, would there be options to buy microwave links at the end of it? And if you could guarantee that there were several companies competing for their business, they were happy. And so the actual, how we ran the auction didn't have, it freed us to not think about many of the issues that let me say, the geography issue that we face so strongly in the U.S. That wasn't really a problem in Mexico. What was the main thing in Mexico that they wanted was to make sure there were at least 3, in the end we guaranteed 10, companies competing for their business.
Got it. And another question, I think this is also very applicable to what you've done, is that, there's this prevailing view in startups that, you make an MVP and you put it out there, right? And so you make a rough version of your website, now it goes and you see whether people like it. When you're designing a more complex system, that can be non-trivial to do, right? So how do you think about testing models when you're building an entire system?
So first, I like to use every tool I've got. I'm a big believer in all the tools that I've got, and those tools include theory and multiple kinds of theory, but they also include experiments. We would often code it up, let college students, mainly because they're cheap, participate in it and see what happened, right? And we would give them incentives, financial incentives, that look like what we understood the customer's incentives to be.
This is actually one of my favorites. Can you say what you did for the Spectrum Auction software?
Yeah, so we hired, and I say we, it was actually a guy named Charlie Plott at Caltech. He coded up the design that Milgram Wilson and I had created, and we first ran it in front of Caltech students. And the thing about Caltech students is that, whenever I taught at Caltech, I was like always the dumbest guy in the room. These people are unbelievable. 2/3 of them get perfect SAT scores. They're really smart, and so we would put it in front of them, because if they can't figure it out, no one's going to figure it out. It's not that this is not where we end. The other thing that we did, though, was we paid them $100 for every bug they found, and a bug could be just anything that they could exploit to change the outcome. Now, this, bug bounties are well known, but this was incredibly productive. I actually think running the software, rather than have a $10,000 prize to the general world, just go have a $100 prize at Caltech. But put it in front of a bunch of them, and especially if you can get them in the mindset of whoever wins the most gets the most status. Like, it's probably rather than give them money, have a plaque, a permanent plaque. So we did that, but then we subjected it to more normal people, and we even actually ran it in front of some telecom executives to actually test it with people who aren't that bright, like me. I mean, it's an unusual experience teaching at Caltech, having students that smart. It's my joke was MIT without the riffraff.
Yeah, I live right near Caltech, so I'm thinking of just going to go over and watch people walk around. Got it. So it sounds like, really the strategy here is, you're using theory to motivate, what do you think is going to happen? And then it's very targeted testing, right? Sort of thinking about where can we put this in the place that will do the least damage to see if it'll actually work.
And testing multiple models against each other. That is to say, we didn't only test these auctions. In fact, one thing that is really impressive about Charlie Plott was he had his own design. And his own experiment showed that his own design was inferior to ours. That's a really great thing, right? This is science at its best.
Yeah, he could have just deleted that data and pretended that it didn't happen.
It didn't happen.
He was an honest experimental guy.
He was completely honest about it. And he's a man of very high moral.
Got it. Okay, so take me to, I'm just curious. So, you send the software to the FCC. They're going to run this $10 billion auction. What are you doing the day it goes live? Are you terrified? How are you feeling?
So as I think I mentioned earlier, we actually ran paging frequencies first. Those were much less valuable. They're tiny slivers of spectrum. And that gave us that was kind of the final test, is to sell a real thing to the real participants using the same design, but with the stakes not so high. We had worked to manage expectations, and it became clear, let me say, really in the first few hours. There was bidding roughly on the hourly basis, as you could revise your bid only upward on an hourly basis, and you could substitute across items. And it became pretty clear that we were going to meet our own definition of what was success looked like. So I didn't spend much time being very nervous about the paging auctions, because we were seeing the substitution that we wanted to see. And the idea of substitution is you want to win Texas, but then the prices get bid up in Texas, so you substitute, say, to Florida. Prices get bid up in Florida, you substitute back to Texas. There's that kind of substitution. We're seeing that on the paging frequencies, both in geographic areas and in bands. That is, when one band is more expensive than another. There were people who wanted to buy multiple bands. It's advantageous to them for the bands to adjoin each other in the space. So that is, if you think about the FM dial, 93.1, 93.2, you want to be adjoining. We were also seeing that. That is to say, we were seeing them. And in the end, it came out as if we had cheated. It was so perfect. So in the end, it looked fantastic. But even before that, by saying, look, what does it mean to be successful? It means there's not much money left on the table. We were pretty comfortable that everyone was behaving right. Now, there's another reason to not be so nervous the first time, and this is going to, it's relevant to other things, is the parties bidding were themselves inexperienced. Now, yes, they had done wargaming inside, and they had done some experimenting on their own to figure out how to participate, but they weren't that experienced. It turns out that the design we had a flaw. It wasn't found in the first auctions. It wasn't even found in the third, the $10 billion auction. It wasn't found until the fourth auction, and it requires someone to be directly harmful to others, and that we hadn't ruled out. The interesting thing was I had actually quit participating in it, went to design auctions in Mexico, figured out this flaw and fixed it in the Mexican auctions, made the flaw not apparent, or no longer exploitable. But meanwhile, they held another block where it was exploited. So there were some things, there were some holes to be plugged that we didn't actually foresee. But as I said, they continue to use the basic auction form.
Yeah, so this brings us to a good point, which is I think the last sort of general topic we want to talk about is sort of the theme of smart contracts and governance, right? So contract theory is a robust area of economics. Information economics is also really important. And, there are a lot of platforms who are saying, great, we never have to have centralized decision makers again, right? We're going to program everything into smart contracts, and it's going to be fantastic. What is your take on that?
Yeah. So, actually, I read somewhere that startups pivot at least. Well, they go through 3 business models, so 2 pivots on average. The average one does that. I don't know if that's true, but it's certainly consistent with the handful that I advise have had to revise their business models, and that's because we don't foresee everything that happens. Nova Scotia contracted in the 1950s with Quebec to supply hydropower for 2 cents a kilowatt hour. They wrote a 50-year contract at a fixed price.
Nominal price.
Fixed nominal price. But the thing is, standing in 1955, there hadn't been a long bout of inflation in U.S. history or North American history. It's kind of not surprising. So I think there are always going to be unforeseen issues. The other thing I like to say about this is that if you actually think you're going to put everything into the contract that matters up front, so you're going to have to think really hard about how governance works and be right. It's a lot easier to say, well, some decisions we're actually going to, well, in fact, what turned out to be really important in the PCS auctions was how it was controlling revisions. You don't want to willy-nilly let people rewrite the contracts completely, but you have to let them rewrite them some because there's circumstances that you really can't foresee or contract on. And so that's part of governance. I doubt that you're ever going to foresee so well that you can just put it all in place. To be fair, one of the things we see, there's actually people who study the evolution of contracts. And there's a paper about oil contracts, kind of apropos of being in Texas. And it turns out what happens in contracts is that everybody writes contracts and they work pretty well, and then somebody finds a loophole in one, or some issue that had never come up comes up. Starting then, new contracts are written with that loophole plugged. And so if you think you're going to get it all in advance, you're going to write a contract that just lasts forever, without ever having a revision or without having a giant like inefficiency built in because, oh, we didn't see that coming. I think I'm skeptical of that ever happening. I'm also a great believer in evolution. That is, I want to learn from mistakes and from what works and what doesn't and incorporate the best practices. And that's hard to do if you've just locked it down.
Got it. Yeah, no, we're definitely in the pro-governance camp here. We believe in lots and lots of governance.
Well, I think governance either way. If you're going to write it, like you need more governance if you're going to say, we're going to write the contract of the universe that's going to last forever. You need a lot of governance to get that right. And it's probably a little bit easier to say, let's delay some of the decisions and let them be made after some time is unfolded.
Yeah. No, I have a friend who worked in dispute resolution in a major company where dispute resolution is quite important. And he's the number one biggest proponent of unforeseen things happen. Some of the stories are just crazy. So just to finish up, I think the last question is, there are blockchain native startups, but there are also enterprises trying to think about how do they make the best use of blockchain. So what is your advice for them on thinking about how to integrate a new technology like this into an existing business?
So the first and foremost is experiment. Find an area where the downside isn't very large, run an experiment. And the thing that's underappreciated about running an experiment is you actually learn from the experiment. Everybody gets that. But you also build capability within your organization. That is, you build people who understand the technology in a way that they hadn't until they'd done the hands-on experiment. And that winds up providing other value you didn't see coming. That is, you get, there'll be other areas where you say, hey, wait a minute, we can apply this technology that we had over here, that we'd experimented with, in a completely different area. And so I think try the experiment, and I don't, it's not that I think you should experiment with everything. I think blockchain is important in the circumstances where we discussed, where it potentially solves a problem. Anytime where you've got these trust issues, blockchain can help. So run an experiment in that arena where you've got trust issues, see how it works, and then look at the team that ran the experiment, who now actually has capability they didn't have before, who can actually figure out other uses for that technology. And so that's kind of my starting point. And then, as I think I already mentioned, I actually think looking at kind of this make or buy, how do I use markets effectively? That's a place where blockchain as a public record can serve a role. And so that is, when you're thinking about using markets more, using blockchain along with it has some advantages.
Sounds good. And you never know what your team of blockchain internal people will come up with. So
absolutely.
All right. So that's actually it for the set of questions that I wanted to go through. We'd be happy to take any questions for Dr. McAfee. And we have a microphone, so I'll pass this back, please.
So you mentioned that people make mistake, and people have behavioral biases, and so you can design a system to fix or help people to actually not make mistakes, or you can design a system to actually exploit people's biases. So when you work for a private enterprise, how do you navigate this tension? Because if you exploit people's biases, you can actually make more profit. So when you design the systems, how do you take that into account?
Yeah, so that's a great question. And usually I frame this as kind of long-term or short-term. So that is, I typically would say that's not my call. I'm going to present options on that. And you can almost think of it as taking the high road, is I'm going to deliver more value to you, or I'm going to exploit. And I'll give a sharp example of this, is so from Amazon, Microsoft, or Google, you could buy storage. And if you go and look at the way that storage was sold, you have Amazon is making, well, it's hard to know how much money they made because they don't report that. But let me say, at the way our customers behave, 50% of the revenue of Amazon, if their customers behave the same, which I don't know, they would get 50% of the revenue in read-write charges. So you see this, price per gigabyte is what everybody focused on. And then meanwhile, there are these read-write charges that are like huge. So we were faced with, do we copy Amazon, which is the only way we could ever get the price per gigabyte down to the Amazon level, or do we try to educate the customer? And that's actually the position I took, was we should probably try to educate the customer. Our customers look different by and large than Amazon's customers. They are mostly with us meaning Microsoft, for the long haul. This is a long-term relationship. Let's talk with them about the differences and why the read-write charges, in some sense, it doesn't do you any good to store something if you can't read it. So if there's a giant read-write charge on it, that's a negative for those customers. Let's talk about that, but let's offer them both. And so that's a way of splitting the differences. Yes, you can get this cheap. It's also a way of pointing out, hey, by the way, when you get this cheap, you're getting these big read-write charges. Whenever I talk about this, because I lived through this particular issue, and I was quite proud of what Microsoft decided, I think, as a parent. Whenever I would talk about this, though, I would always talk about Blockbuster and the fact that 50% of Blockbuster's revenues came from late charges. And that's a bad place to be. Right? That's what you deserve to go bankrupt. When that's your business model, it's not a long-run business model. There are lots of situations where you just need the money. Like I advise startups, they live very much hand to mouth. There are times where this looks like you're exploiting somebody, but they actually are kind of an active participant. Let me give the example of credit cards. Borrowing money with a credit card is an incredibly bad deal. You're paying 24% a year. The bank's make a fortune on people who borrow money on credit cards. It's an incredibly bad deal. The data say about a third of people pay interest on credit cards, and they do so systematically. That is, they don't ever stop. At some point, you have to say, okay, this is what they're choosing. It's not like they've been in this business long enough to know that, okay, this is a choice. It's not and so I kind of don't want to stand too much on saying, yeah, this is just a bad deal, because that's what it looks like to me. But they're actually systematically choosing that. Okay, you should exploit that if they, and maybe it's actually good for them. I don't believe that about credit cards. Let me just be on record that I do not believe that about credit cards. But nonetheless, when they make that choice, that's and actually, I thought I was done, but I've got a fourth thing, which is there are at least 9 different ways you can exploit people behaviorally in pricing. That is, I have a list of 9. And there are at least 9, and there are things like anchoring.
We will be auctioning that list at the end of this discussion.
Reference pricing and so on, So fake sales, right, is I raise my price and then I take 50% off. So there are a bunch of those things where they do this. These make a little bit of money. They're by and large gimmicks. You're not going to like make a fortune on this. You collect a little bit of cash, but mostly too, you don't piss people off. I mean, that is to say, ending your price at 9, nobody's fooled by that, except people who are trying to be fooled by that. That is the person who's trying to talk themselves into, oh yeah, it's only $9, it's not $10, the $9.99 item, because they want to they're trying to talk themselves into buying it. You might actually be doing them a service, or maybe not. It's hard to know, but they are active in the process in this process, and so that. Fortunately, working for Microsoft, they mostly take the high road because they make almost all their money off big companies. They don't like you need to deal with them in a straight way. They're not happy about being tricked, and so that's not a way Microsoft does business typically. And that made me sleep better.
All right. Any further questions?
Are there any blockchain systems that you think are designed really well?
Any existing blockchain? We should have talked about this before. there's a bank that is actually making a lot of well, all right. So the answer, the root answer is no. I'm probably not in the top third of people in this room to give the answer to that question. So I'm going to shut up as soon as I can. But I'm impressed with Ethereum, mainly because they upped it a level. They did it a meta level, is that they said, you write the contract, use Ethereum as the mechanism for writing the contract. What's wonderful about that is that you then let evolution figure out what's the right solution. So if you don't know the solution, let evolution do it. So Ethereum, I think, was really smart in their design in a way that no one else was. I mean, that is to say, they got out there first and fast with a really innovative design. And then there's a bank who's slipping my mind that is actually doing a lot in blockchain. Yeah, so there you go. There's a bunch of banks that are doing a lot, and but I don't really know enough to say whether they're doing a great job or not. I love the experimentation. I love the fact that they're putting it in practice and learning about it.
I have a quick question. So as an economist, what are your thoughts about stable coins?
Yeah, so when that first came out, I have a bunch of friends who do it's really a macro issue. I'm a micro guy. You probably shouldn't listen to me about macro issues. I flunked my first attempt at the qualifier in macro. In a way, that's a badge of honor. And that's really a macro issue, is whether you can pull that off. I almost immediately called up my friends who are much more expert than I am and said, can you make this work? And the interesting thing, that is, the issue here is, can I back it with something? So can I peg it to the U.S. dollar and back it to in a sufficient way to convince everyone that it is for sure backed? It won't, there won't be a run on the bank. And that causes the currency to fall in value because they've got adequate backing. And obviously, if you have 100% reserves, you can do that. So if that is for every dollar you issued, but of course you're not actually making any money if you're doing that, right? That's not a profitable strategy. That's a break-even strategy. So no one in their right mind, and you've got costs. So really, it's a guarantee of a loss if you follow that strategy. And then the question is that can you do it with less? And let me say, there's a giant literature about runs on the bank, and during the Great Depression, Utah had no banks fail, and here's how that happened. There's a particular guy who worked for the Federal Reserve, who got a bunch of cash, and whenever a run started, he drove to that bank with a trunk full of cash, and they gave out all the cash. People would hold the cash for 2 or 3 days. I mean, he gave out, equal to whatever the bank's obligations were. They would hold the cash for 2 or 3 days, and then when it didn't seem like the bank was going to fail, they'd bring it back. He'd then take the money and put it back in the trunk and drive off to the next one. That's how they kept that bank alive. The conventional wisdom is, you need 5%, something like that, to make it really unlikely that you have a run on the bank. But as soon as it starts to run, you need a safety relief valve, and that has to be bigger than stablecoin itself. It has to be a consortium of stablecoins, and even then you're not guaranteed, because you're only guaranteed that if it's independent runs as opposed to correlated runs. You can defend against independent runs. This is what insurance is all about. It's not like insurance companies can definitely pay if there's a natural disaster. It's just that they are designed so that with high probability they can pay because they have enough backup, and they try to make the risks uncorrelated. So it's a really wonderful question. So in the end, but all of the people not all of the people, many of the people I talked to said, yeah, but it's kind of hard to know. Now, if you didn't try to do literally stablecoin, where they're saying, parity, but said, we're going to put a lower bound on it. It will never go below this. It's allowed to float up and down, but we've got a low, it's what they call a crawling peg. It's never going to go below this, never going to, if it goes above it, we'll start buying it, keep it in that range. We did that, Bretton Woods did that with the exchange rates forever. And the final thing I'll say on this is that something that people often don't know is that we actually try to peg the U.S. currency against the euro and other currencies. Again, crawling peg. We're not saying absolutely they can't move, but we try to do this. Europeans do this. Everybody does this. We all do this. And the thing that's astounding is all of those central banks make money doing this. That's a profitable thing. They don't lose money at it. They make money at it. They make a lot of money at it. This is, billions, hundreds of billions in the U.S. It's a substantial amount of money is made stabilizing the currencies. So that suggests if you can get this right, and again, it probably isn't pegging it against the dollar, it's more pegging it against some other market basket with other participants who are also pegging, that is, all of you are pegging, you got a much better shot at it than if you try to peg it against the US dollar. Final thing I'll say is for years, the Hong Kong pegged against the US dollar, and they successfully did that. But they did that with the, they printed their own currencies and just they bought and sold and held enough. And again, you don't need to hold 100% unless you want to guarantee it for sure. And so, yeah, if they're making money at it, you keep some segment of that, and you can make that the probability that you can winter or survive a run better and better. Did I answer your question?
Any further questions?
So the past few years, a lot of blockchain projects have incorporated the use of a token to kind of either kickstart their economy or incentivize certain user activity. What are your thoughts on using a token to kind of create a little mini economy for a certain project? Do you think that's a viable strategy, or do you think people can still achieve incentive mechanisms without a token?
So I got a two-part answer. One is you got to look at the right setting. So a sharp example of when a token is a smart idea is that I've got a game, I've got in-game stuff. I want to monetize that. I want to allow some mechanism for transferring dollars in and out. A token is a pretty natural way to do that. It's a very sensible way to do that, and you even see some of them. And that fits our earlier discussion of fitting the technology, using the tool in the toolkit for the right problem. There's some settings where it's a very natural thing. I also think there's been so much fraud in the initial coin offering that in any other setting I'd be really leery about it, because I think you had a whole bunch of what amounted to just blatant attempts to rip money off from investors that a lot of people now are really gun shy about it. And so using that strategy, unless you've got a very good story about why a coin is the right thing for this setting, I would actually try to shy away and use a different mechanism just simply because of the negative PR that's been attached to them. That's something presumably that will go away. That is, people have gotten more savvy about and more skeptical about ICOs, and then that will get them not to, once they've gotten over that, we haven't seen so many fraudulent ones that then it will expand in its use cases.
And I think just another additional benefit we see is that there's a tendency for people to think that the only thing they need to do to design incentives is to introduce a token, right? So if you sort of say, okay, tokens off the table, it gets people thinking about some of the other, contexts, all the things we've been talking about. In terms of market design are currency agnostic, basically, unless you're using like the Venezuelan currency. So, there's a lot of levers that can be used to think about incentive design.
Yeah, that's a really good point. Is that and I think actually the kind of the mania that went on with coins because of the price of Bitcoin mostly that really distorted people's views. Also detract from good company design. How a company is internally organized is probably more important than how you fund it in the end. I mean, at least to the longevity of the company.
All right. Additional questions?
One more, anybody? One last question.
All right, so thank you all for coming. As you know, there will be refreshments drinks and light food served after this, and we hope that you'll stay and say hi and ask any other questions that you might have. Oh, it's going to be brought in here. So, all right. Thank you very much, everybody. And thank you, Dr. McAfee, for joining us.
Thank you.